Okay, good afternoon, all of you. Welcome back. I hope you all had good lunch. And so we shall proceed with our continuation part. So hope you all can hear me. Somebody answer. Am I audible to all?
Yes, sir.
Yes, am I audible to all?
Yes, sir.
Yes, sir.
Can you hear me?
Yes, sir.
Somebody answer me, please. Well, we are to continue from the sedimentation behaviors of flocculated and deflocculated suspensions. I already explained you what happens, what will be the sedimentation behavior, or what will be the settling down behavior of the particles in a flocculated suspension already, right? Let me recall fastly. In flocculated suspension, the formed flocks are called as loose aggregates, and these loose aggregates will cause increase in sedimentation rate due to increase in size of sedimenting particles. Hence, the flocculated suspensions sediment more rapidly and more fastly. And in this case, the sedimentation depends not only on the size of the flocks, but also on the porosity of the flocks. In flocculated suspensions, the loose structure of the rapidly sedimenting flocks tend to preserve the sediment, which contain an appreciable amount of entrapped liquid, and the volume of the final sediment thus relatively large, and it is easily redispersible by agitation, by doing agitation or by shaking, right? So this is what happening in case of flocculated suspensions. Now let us see what is happening in case of deflocculated suspensions. So in case of deflocculated suspensions, the individual particles are settling, so the rate of sedimentation is slow when you compare with flocculated suspensions. And this, in this case, it prevents the entrapment of liquid medium, which makes it difficult to redisperse by agitation or even by shaking. And this phenomena is also called as cracking, or you can also call it as claying, right? Cracking, in the sense, cracking of the suspension. Claying means it forms a cake which looks like a what do you call piece of clay, right? A clay cake made up of a clay. You know clay and mathematics. I hope you understand what is the meaning of clay. C-L-A-Y. And the process is called as claying or cracking. In case of deflocculated suspensions, the larger particles settle fast and smaller remain in supernatant liquids. So the supernatant liquid appears cloudy, whereby in flocculated suspension, even the smallest particles are involved in the formation of flocks. So the supernatant does not appear cloudy. So what is the difference here? In case of sedimentation behavior, when you compare with deflocculated suspension, in case of deflocculated suspension, water settling down, water sedimenting down, the sedimentation is by the individual particles themselves. The individual particles themselves, they settle down in case of deflocculated suspensions. Whereas in case of flocculated suspensions, what is happening? Initially, the smaller particles are getting precipitated, and these precipitated will deposit on the surfaces of the larger particles. That means when you consider a spherical particle, the entire surface of the spherical particle will have a layer of smaller particle precipitate, and gradually the layers will increase as the precipitate increases. And thereby the particle will become denser and they settle down and they form loose flocks. Right? And in case of deflocculated suspension, what is happening? The larger particles, they themselves, they start settling down. Okay? Fine. And what is the difference? In this case, the phenomena is also called as cracking or claying. And what they say at the last point is, in case of flocculated suspension, after sedimentation, that means after all the particles are settling at the bottom, the supernatant liquid, that means the liquid left over above the sediment which is formed at the bottom, will be very clear and transparent. And whereas in case of deflocculated system, the supernatant liquid will be cloudy. That's what they say. In deflocculated suspension, larger particles settle down faster and smaller remain in supernatant liquid. For that reason, the supernatant liquid appears cloudy, whereby in flocculated suspensions, even the smallest particles are involved in flocks and they are settling down. So the supernatant liquid does not appear cloudy. It will be very clear and transparent. So hope it is clear to all of you about the sedimentation behavior in case of flocculated suspensions as well as in case of deflocculated suspensions. Well, so next is a diagram. There is a picture, right? So you can see in slide number 23, right? So one side, that is, if you consider your left hand side, one above the other, there are three diagrams represented there, right? So first they are mentioned the time duration, that is storage period or period of standing, that is short period, that will be counted in terms of minutes. And the second one is the median period, that is counted in terms of days or hours. Long period, which is counted in terms of weeks or years. So these are storage duration, right, or period of standing. Then next, second, at the middle, you can see the changes or sedimentation behavior happening in case of flocculated suspensions. And at the last, in the third, you can see the sedimentation behavior of deflocculated suspensions. Okay, let me explain one by one. Let us go to flocculated suspension. What is happening to the sedimentation pattern in case of flocculated suspension in short period? If you consider couple of minutes of storage, you can see there is sedimentation, and you can see the clear supernatant liquid, and sediment is, somewhat cloudy, which is represented as striations or crossed lines. And you see, when you prolong the storage, that is, if it is stored for a medium period, for hours or for days together, you can see the supernatant region increased and sediment is, the cloudy region is decreased. And on long period, very long period, for a couple of weeks or years, then you see there is again further increase in supernatant region, and the sediment region is compressed, right? Similarly, if you consider the pattern or the sedimentation behavior in the case of deflocculated suspensions, in the first diagram you can observe that is representing results after short period of storage. You can see what is happening, no much change in initial sedimentation, right? Because we all know that In case of deflocculated suspensions, the sedimentation takes place slowly, right? Because initially the smaller particles have to precipitate on the surface of the larger particles and forms layer by layer, and then they should start sinking the larger particle. I cannot use the term sinking. They should start sedimenting the larger particles to the bottom direction. And for that reason, it will take longer duration. At short period of time, there is no much sedimentation. And on medium duration, after a couple of hours or couple of days, you can see there is a little amount of sediment formed at the bottom. And gradually, if it is continued for long period, for example, couple of weeks or for a year, then you can see the sediment is very strong and very tightly bound, and a cake formation has been represented there. And this is also called as claying or cake formation, right? Hope you understand by looking at the diagrams. Pavan, is that clear? Pavan?
Yes, sir. Yes, sir.
Okay. And who else is there? Lakshmi, are you there? Dasari Lakshmi?
Yes, sir.
Is that clear, ma? Everything is clear?
Yes, sir.
Joshna, are you there? Joshna? Joshna?
Yes, sir. Yes,
Joshna, roll number 28, Joshna. Yes. Fine.
Yes, sir.
Fine. Kalyan? Kalyan?
Sir.
Is that clear? Is that clear, Kalyan?
Yes, sir. Yes, sir.
Sedimentation behavior in both the cases, right? Flocculated suspensions as well as deflocculated suspensions. Well, now we are looking to the next pattern, that is Brownian movement, right? So, anything there, Pawan?
సార్ బ్యాక్ మీటింగ్ బ్యాక్ వచ్చి స్లైడ్స్ చూసుకుంటుంటే వీడియో ప్లే కావట్లేదు సార్.
నేను పంపిస్తాను మళ్ళీ మీకు. ప్రీవియస్ వీడియో నేను కన్వర్ట్ చేయాలి. జూమ్ ఫార్మాట్ లో రికార్డ్ అవుతుంది. I have to convert it and send it to you later. In my system, it is recording. So what you want me to do in the settings? There is some issue, some problem with my computer. నా కంప్యూటర్లో ఏదో ప్రాబ్లం ఉంది, స్క్రీన్ షేర్ కావడం లేదు. సెట్టింగ్స్కి వెళ్తే అది ఏదో చూపిస్తుంది, కానీ ఏం చేంజ్ చేసినా కావట్లేదు. ఓకే, రికార్డ్ అవుతుంది ఇప్పుడు. నౌ ఇట్ ఈస్ గెటింగ్ రికార్డెడ్. సో వన్స్ ఇట్ ఈస్ డన్, ఐ విల్ షేర్ ద రికార్డింగ్ టు యూ. డోంట్ వరీ. Fine. And Nagalakshmi, please on your camera. Pujita on your camera. Preeti on your camera. Many people are not switching on your cameras. Right? Right. Let me check now whether I can share. No, screen sharing has failed. To start, please try again later. Error code 105035. That is what showing in my computer.
సార్ మోర్లో క్లిక్ చేస్తే సెట్టింగ్స్ వస్తాయి కదా సార్, దాంట్లో అలో పార్టిసిపెంట్స్ టు షేర్ అంటుంది.
మోర్లో సెట్టింగ్స్ లో ఒక నిమిషం,
మీటింగ్ సెట్టింగ్స్ వస్తాయి కదా సార్, మోర్ క్లిక్ చేస్తే.
మోర్లో చాట్ ఉంది, స్టాప్ రికార్డింగ్ ఉంది, పాస్ రికార్డింగ్ ఉంది. సెట్టింగ్స్
లేదా సార్?
హోమ్కి వెళ్ళాలి. నేను సెట్టింగ్స్ చూడాలంటే ఐ హావ్ టు గో టు మై హోమ్.
సార్
షేర్ స్క్రీన్, ఎస్. No, still it is coming soon. ఇప్పుడు షేర్ అవుతుందా? Anybody can see now?
No, sir.
No. Fine, let us not waste time for this, right? మీ దగ్గర ఉన్నాయా స్లైడ్స్? ఉన్నాయి కదా మీ దగ్గర, హ్యాండ్ అవుట్స్? I already said. Please keep watching them. Yeah. Fine. Next is Brownian movement of the suspended particles. This Brownian movement is also called as drunken walk, right? Drunken walk. ఒక డ్రింక్ చేసిన పర్సన్ ఎలా వాక్ చేస్తాడో అలా మూవ్ అవుతుంటాయి అనమాట ఈ పార్టికల్స్, సస్పెండెడ్ పార్టికల్స్. Well, let us see what is the role of Brownian movement in case of our suspension. Brownian movement of particle prevents sedimentation by keeping the dispersed material in random motion. Right? Brownian motion we already discussed, right? Previously, I explained you like the suspended particles will be like Tyndall effect. I explained you previously, right?
Yes, sir.
Okay, fine. This Brownian moment depends on the density of the dispersed phase and the density and viscosity of the dispersed medium. This Brownian moment depends upon how viscous the liquid is and what is the density of the suspended particle. These two factors majorly plays major role in Brownian moment. The kinetic bombardment of the particles by the molecules of the suspended medium will keep the particles suspending, provided that their size is below critical radius, which is represented as R. And the Brownian moment can be observed in particle size, which is about 2 to 5 millimeters. Sorry, 2 to 5 millimeters. If the particles are up to about 2 micron in diameter are observed under microscope, or the light scattered by the colloidal particle is viewed using ultra microscope, and the erratic motion seen is referred to as the Brownian movement. And this typical motion, that is the Brownian movement or Brownian motion of the smallest particles in the pharmaceutical suspension, is usually eliminated by dispersing the sample in 50% glycerin solution having a viscosity of about 5 CPS. Right? So you understand the Brownian movement. What is the Brownian movement? Normally, the smallest particles will have motion. They will be, moving from one place to another place, right? Like a drunken walk. And thus, that type of movement is possibly observed in particles having size range between 2 to 5 mm, right? Or even 2 micron or below, they can be observed under microscope, right? And this, due to this Brownian movement, there may be possibility of sedimentation will be more. And this can be avoided by using 50% glycerin solution, which is having higher viscosity of about 5 CPS, right? So let us not go much deep into the technical oriented objective, because you all will be studying suspensions and their technology again back when you go to third year, right? In your third year, you study again formulation. There you will study all this, right? Now, let us look into the next subheading, that is flocculating agents. So now we know what are flocks and what are flocculated suspension. Yes or not? Sadar Pasha? Sadar Pasha?
Sir.
Can you tell me what is a flock?
Sir, your voice is breaking, sir.
Can you tell me what is a flock? Flock. FLOCK. Sorry, FLOC.
Sir, round ఉండగా sir.
Flock ante enti? Flocks ante enti? Or else floccules ante enti? What is the meaning of floccules? Forgotten already, huh? Flocculation
No,
occurs.
sir.
Do you remember where it occurs? In flocculated suspension or deflocculated? Yashashwini, can you answer?
Sir, flocculated substance.
Yashashwini.
The forming of particles, aggregation of the particles.
Aggregation of particles, loose aggregation, right? Not exactly compact aggregation, loosely aggregated particles, smaller particles, right? They tend to form aggregates, and those aggregates are called flocks. Do you remember the size approximately? What is the size of a flock in diameter? Don't remember. Fine, not a matter. You refer back, right?
Yeah, sir.
Yeah. Okay, not a problem. Not a problem. You can refer back and remember. Fine. Then coming to Kalyan. Kalyan.
Sir.
చెప్పనా ఫ్లాక్యూల్స్ ఎందులో ఉంటాయి, ఎక్కడ ఉంటాయి, ఏ టైప్ ఆఫ్ సస్పెన్షన్ లో ఉంటాయి ఫ్లాక్యూల్స్ ఏ టైప్ సస్పెన్షన్ లో ఉంటాయి? ఫ్లాక్యులేటెడ్ లోనా, డీఫ్లాక్యులేటెడ్ లోనా?
Flock.
చెప్పు కళ్యాణ్, నువ్వు చెప్పకపోతే అశ్విని చెప్తారు ఇప్పుడు.
Flockulated suspension.
ఫ్లాక్యులేటెడ్ సస్పెన్షన్
suspension, sir.
కరెక్టేనా అశ్విని? అశ్విని కరెక్ట్ అమ్మా? ఫ్లాక్యులేటెడ్ సస్పెన్షన్.
Yes, sir.
కళ్యాణ్కి వాట్సాప్ మెసేజ్ వచ్చింది ఆల్రెడీ, అది చూసి చెప్తున్నాడు. ఏం కళ్యాణ్, మెసేజ్ పెట్టారా నీకు?
No, sir. No, sir.
Fine. Well, now we shall look into flocculating agents. So agents అంటే ఎవరు? వాళ్ళు CBI agents ఆ, FBI agents ఆ, ISI agents ఆ? కాదు. ఏ ఏజెంట్స్ వాళ్ళు? flocculating agents అంటే those are intermediate substances which are added to enhance floccule formation, right? Flocculation agents, when they are added into suspension, they decrease zeta potential of the suspended charged particles and thus causes aggregation. That aggregation is called as flock formation of the particles. For example, we have intermediate agents which are acting as flocculating agents. Material or substances like neutral electrolytes such as potassium chloride and sodium chloride, calcium salts, alum, sulfates, citrates, phosphates, and other salts. And neutral electrolytes, for example, sodium chloride and potassium chloride, besides acting as flocculating agents, they also decreases the interfacial tension of the surfactant solution. If the particles are having less surface charge, then the monovalent ions are sufficient to cause flocculation. For example, steroidal drugs. For highly charged particles, for example, insoluble polymers and polyelectrolyte species, di or trivalent flocculating agents are used, right? So these are few examples for flocculating agents. Flocculating agents are used for the reason why they are used. They are used for the reason to enhance the formation of floccules. Why we need to enhance the formation of floccules? Because the floccules can be redispersible easily, right? So that is the purpose. Now, just running short of time, right? How much time is there? Another 3 minutes there. So in case if it shut down automatically, I inform everybody to rejoin again, right? With the same link you can rejoin, or you want me to send another link?
Same link.
Okay, send another link. Another link అంటే ఇంకో 10 minutes అవుతుంది. మళ్ళీ మీకు ఇంకో క్లాస్ ఉందేమో నెక్స్ట్ అవర్. ఆర్గానిక్ కెమిస్ట్రీ ఏదో ఉన్నట్టుంది.
అవును సార్.
ఆర్గానిక్ క్లాస్.
ఫైన్. ఇదే ఇందులోకే జాయిన్ కావాలని చేయండి, స్టార్ట్ చేయండి. In case if we can rejoin into the same session with the same link, we'll continue, or else we'll continue tomorrow. Fine. Now, is that clear? Flocculating agents, everybody? Flocculating agents and their examples. Now we shall look into the flocculated systems. In these systems, again, it's a recall. It's a repetition actually. I'm just recalling everything. In this system of flocculated suspensions, the dispersed phase is in the form of large fluffy agglomerates. Agglomerates means aggregates, where individual particles are weakly bonded with each other. This I already explained you. As the size of the sedimenting units is increased, flocculation results in rapid rate of sedimentation. The rate of sedimentation is dependent on the size of the flocks and porosity. This is also repeated. Flock formation of particles decreases the surface free energy between the particles and liquid medium, thus acquiring a thermodynamic stability. And the structure of flocks is maintained in sediments, so they contain small amount of liquid which is entrapped within the flocks. The entrapment of liquid within the flocks increases the sedimentation volume, and the sediment is easily redispersed by small amount of agitation. This is just a repetition and it is for your recall. And now to formulate flocculated suspension system, there are two important steps which need to be remembered by you all to formulate a flocculated suspension. The wetting of particles and controlled flocculation. The primary step in formulation is that adequate wetting of particle is ensured, and a suitable amount of wetting agents solve this problem. Thereby, you can selectively choose an appropriate wetting agent or a combination of wetting agents, which is described under wetting agents category. And a careful control of flocculation is required to ensure that the product can be easily administered. Such control is usually achieved by using optimum concentration of electrolytes, surface active agents, and or polymers. And change in these concentrations may change suspension from flocculated to deflocculated state. Now, can you guys tell me, among these two types of suspensions, flocculated and deflocculated suspensions, which type of suspension is better one? Which type of suspension is better comparatively? Everybody, please answer. Let me know your answers.
Flocculated better, sir.
Flocculated suspension.
Flocculated. అందరు గట్టిగా అరవాలి. ఎందుకు?
రీడిస్పర్సిబిలిటీ బాగుంటుంది సార్.
చిక్కుపడ్డా మనము చిక్కు తీసుకోవచ్చు. ప్రాబ్లం ని మనం సాల్వ్ చేసుకోవచ్చు జస్ట్ బై సింపుల్ అజిటేషన్. ఇప్పుడు మీరు ముఖ్యంగా గుర్తుపెట్టుకోవాల్సింది ఏమంటే, ఫ్లాకులేటెడ్ సస్పెన్షన్స్ లో ప్రాపర్టీస్ ఏంటి, డీఫ్లాకులేటెడ్ సస్పెన్షన్స్ లో ప్రాపర్టీస్ ఏంటి, సెడిమెంటేషన్ బిహేవియర్స్ ఎలా ఉంటాయి, ఎలా సెడిమెంట్ అవుతాయి, సెడిమెంట్ అయిన తర్వాత ఏం జరుగుతుంది. ఇన్ కేస్ ఆఫ్ flocculated suspension, you can see the sediment form, and that sediment can be redispersible by shaking. Whereas deflocculated suspensions lo emoutundi, cake form avutundi kada. Edo chirunavu avutunnadu Pavan. Em Pavan?
అదే సార్, కేక్ ఫామ్ అవుతుంది సార్.
కేక్ అంటే తినే కేక్ కాదు నాన్న.
అదే సార్,
పెదాలు తడుపుకుంటున్నావు. ఆ కేక్ ఒకవేళ చాలా స్ట్రాంగ్ అయ్యి క్లేయింగ్ అయిందంటే ఇట్ కెనాట్ బి రీడిస్పర్సిబుల్. ఆ సస్పెన్షన్ పనికిరాదు, రైట్? కాబట్టి మనకి ఫ్లాకులేటెడ్ సస్పెన్షన్స్ ఆర్ బెటర్. అండ్ ఫ్లాకులేటెడ్ సస్పెన్షన్ చేసుకోవాలంటే మనం కొద్దిగా ఫ్లాకులేటింగ్ ఏజెంట్స్ గురించి కూడా మనం తెలుసుకోవాలి కదా. వీ షుడ్ ఆల్సో నో అబౌట్ ఫ్లాకులేటింగ్ ఏజెంట్స్, రైట్? అందుకే మనకి ఫ్లాకులేటింగ్ ఏజెంట్స్ కొన్ని ఎగ్జాంపుల్స్ ఉన్నాయి. ఫ్లాకులేటింగ్ ఏజెంట్స్ ఎగ్జాంపుల్స్ are calcium salts, natural neutral electrolytes, etc. Right? Namaskaram.